Okay, since the max is up here at 3 and the min is down here at -2, that means that our midline is halfway in between at a positive 1/2. So my midline is at y equals 1/2. And then my amplitude is again the distance between here or the distance here. So you could have done that, or you could have used our formula 1/2 max value minus min value, which would get you to the same 2.5. So hopefully you guys agree with what just happened there. A couple more. Error analysis. A student looked at the following function and wrote that the amplitude was 2. Describe and correct the student's error. So probably what happened here, we don't actually know, we can't read people's minds, but I'm looking at a max here of 2. So the difference between the min and the max is 2, but the amplitude is supposed to be the difference between the midline and the maximum, or the midline and the minimum. So your amplitude here should really just have been 1. These last two here on this page are looking at just the idea of a periodic function and the fact that it repeats. So suppose f is a periodic function. If the period of f is 5, f of 1 is 2, what's f of 6 and f of 11? Notice f of 1 was given, and then I went to f of 6. That's a difference of 5, which is my period. So we don't know what this function looks like, but every 5 units, it's going to repeat. So if at 1 it was 2, 5 units later at 6, it should also be 2. 5 units later at 11, it should still be 2. So that idea of the repeating cycle is what allows us to know the values 5 units later because of our period. Number 6, a wave has a maximum value of 6. If its midline is 1, what's its minimum? So again, think about the fact that your maximum's up here at 6, your midline's at 1, your minimum needs to be basically symmetric here. So we had a difference of 5 between the max and the midline, which means I need a difference of 5 between the midline and the minimum. So 1 minus 5 puts my minimum value at a -4. So quick recap, you use what values to compute the amplitude. So if you picture your graph, amplitude, you're looking at a vertical distance. So that means you're using y values. You use what values to compute the period? Well, the period is the length of this full cycle. So that's across your x-axis. If I asked you to sketch a graph of a periodic function with a period of 2 and an amplitude of 1, could you do it? Hopefully the answer is yes. You do have options. You can figure out, you don't have to start at the origin, you can start up here. My instinct usually is to start at the origin, so if I draw one full cycle back to the origin here, I want this period to be at 2, then that means this has to be at 2 because I started at 0. So this is actually going to cross at a 1. That was part of the problem, but fun fact. And if I want my amplitude to be a 1, then I have to label the axis up here 1 and down here at -1. So that way this distance between the midline and the maximum is 1, and same for the minimum. So why don't you guys take a second and try to sketch the graph of a periodic function with a period of 3 and an amplitude of 2. Go ahead and pause me while you do that. Perhaps you came up with something like this. Again, it is open-ended, so it could look different. But notice I have one full cycle from 0 to 3, so that's where I'm going to get a period of 3. And I labeled my max and min since I did start at 0. My amplitude is going to be easy because I can label my maximum at 2 and my minimum at -2. Alright, last but not least, which of the following could be represented by a periodic function? So read these choices and choose your answers. Did you get A, C, and D? Hopefully. Again, remember, a periodic function is something that's repeating over a cycle. So the average monthly temperature in Libertyville recorded every month for 3 years. You're going to go through the cycles of seasons. So you're going to have similar temperatures that are repeating. The population of the U.S. recorded every year, well, that is not necessarily repeating, so it's not periodic. The number of cars per hour that pass through the intersection in front of the school on Monday through Friday. You're going to get a repeating pattern here. Around 7 a.m. there's a lot of traffic because people are coming into school. At 7 p.m., not so much, but then the next day at 7 a.m., it kind of spikes again. So you're going to have that repeating pattern. The height of a carousel horse during a 3-minute ride. So this is like on your merry-go-round. If you're riding your horse, you can picture the horses kind of go up and down while that music plays. And you will have, again, a repeating pattern. So your homework tonight is Math Excel. Don't forget, you can always use the Help Me Solve This, Show Me an Example if you need to go into more detail.